implement a print function of the binary search tree so you can print the internal structure, internal links between those nodes. We have seen that through debugger console though, but let's find a way to print it on the screen conveniently so that as we further implement operations of binary search tree, you can debug by visually printing the structure of that. So what we are going to implement is as we call print function, which prints some kind of internal links so that we can verify that binary search tree is correctly constructed after some operations. So here we also use the recursive design. So here we have a binary search tree, root, left subtree, and right subtree. In print function, we are going to print the data at the root node. So if it's a 5, we are going to print a 5, and then we are going to print the left subtree root node, the right subtree root node. Suppose we have a 4 and 7, then 4 and 7 is printed. This is for left subtree, this is for right subtree root node. And then in Tron, and then for 4, we are going to print the left and right and so on. So just to display in this format, and by examining the value, you can verify the structure. So the recursive design is that assume that smaller subtree, smaller size tree, we know how to print this way. Then how do we solve for the entire size? So induction hypothesis is that we know how to do so. Left subtree is a smaller size. Right subtree, we know how to do so. That's induction hypothesis. Then what is the known fact? Known fact is print the value on the root and then do left subtree and do right subtree. That's the way you know. So we need to have a function which tells on which tree we need to operate on. So in like insert the case in publicly, the function is a void print. And the const function, since we don't change any structure of the tree at all, then an internal design, let's name it as a printer, we need to give a root node of the tree. So on which node we want to print, that's also const function. So we need to design something like this. So actual implementation, void ps3 print, which will call print then root p. For this tree, apply printer, then print with some root node is provided, then now we could design a recursively. So if root is empty, there's a zero size tree, then done. We don't need to print anything at all. Otherwise, root is not null, so let's print the value, and root data is printed. Then let's give this marking there with a blank. So we are going to print the 5 and arrow, then continue to print left and right of the tree, left and right of the node. We are going to print the root node the value like 4 and 7 and the like. So we are printing the one, and then if our left is empty, then we just print empty there. Else we can print the actual value on there. So let's have parenthesis open, left data, close parenthesis there. So that's for left hand side. Similarly, we could do on right hand side. So let me copy those two lines, and then we do similarly for right subtree and right subtree. When we complete the right subtree, let's give a line break there. Then we have done on root 1, then we need to do same thing for left subtree and then right subtree. And left subtree is a smaller size, so applying induction hypothesis. So simply call print left subtree if left subtree is not null. So if left subtree is not null, not empty, then print left subtree. Similarly, if right subtree is not empty, then print right subtree. There. So why do I have error message here? Expected statement. So do that. So I gave 2 semicolon that causes an error. Okay, let's test the program. Terminal, compile, clear, and run it. So that's what you got. So let's verify that and clear the screen. And then for this, what you get is 5, and then 4, 7 is on the right, and then 3 is there. So 4 right is empty, 7 both the right and left are empty, 3 left and right are empty. So as to 5, left is 4, right is 7. As for 4, left is 3 and empty. As for 3, empty, empty. 7, empty, empty. So using this display, we can verify the internal structure of a binary search tree, and then we are going to use this print function as we do some other operations to verify the internal structure of the binary search tree.